Hello everybody, welcome to Blue Marble Science. These two nincompoops think they can lay LIGO to rest. Personally, I don't think either one of them could lay a dead chicken to rest. Warning, severe facial and monitor damage alert is in effect. Get out those oven mitts, push the monitors back out of punching range, and let's light this dumpster fire and have some fun. Well, first up we got Brian Leakey, who cleverly listened to the LIGO presentation and failed to learn one damn thing. Give a listen to this. Well, all the information is laying right there. I told everybody how to find it, where it was, where to go get it. So, take a crack at it.
Yeah, man. Look, we've went through all this too. We're just trying to prove one way or another what it is. Because I mean, of course, we've already came up with all that math that shows that, yeah, if the LIGO is on a curved Earth.
Well, if you've already shown a curved Earth, what are you complaining about? What's the problem?
Is exactly what it would have to be, and that's what we're trying to prove, man. You didn't prove nothing with that video.
So you don't think it's a curved Earth? I'm confused.
You just proved what it would be on a globe Earth.
So when they would give the surveyors that the LIGO proves that
hold on, Bob. Hold on, pal. Let me make a statement.
A curved Earth. Why are you still arguing for flat Earth?
Let me make my statement, okay? We already know all this stuff. We've already been over it. Now, what they would have did is give the surveyors a benchmark, and the surveyors would have made two straight lines.
I'm going to go out on a limb here and guess that there might have been a little bit more involved than just making two straight lines, Brian.
Okay. Now, what's underneath it's what we're trying to prove. Not that LIGO's straight, not what it would be on a flat Earth, what it would be on a globe. We're trying to see, was I shooting, when I was surveying it, was I shooting my way around the globe? Or was I going straight for what I'm seeing, basically, point to point? Am I leapfrogging going straight, or am I curving around the globe? That's what we're trying to prove here. That doesn't prove the Earth's curve. That just proves what it would be on a curved Earth.
Blue's video just conclusively proved the curved Earth. So, I mean...
Well, that's why I'm trying to bring a little honesty. Trying to bring a little honesty to the stream, okay?
That is honesty.
I listened to that 6 times and I still don't know what the hell he said. These are actual elevations. Brian, move, you're in the way.
Trying to bring a little honesty to the stream.
Well, that's fine, but be honest somewhere else. You're blocking the screen. Okay, thanks. Look, these are elevations, and it doesn't make any difference whether the Earth is flat or spherical. These are elevations above mean sea level. They're not imaginary, they're not disputed. They are actual physical elevations of two concrete pads. That's what they are. Maybe I didn't explain the other part of it correctly. Let's try that again. I'll make this short and sweet. The LIGO tubes are straight. We know they're straight. That means the concrete pad they're sitting on also has to be pretty straight. We don't need water levels or fishing line or divining rods or holy books to figure this out. We only need 3 elevations, one at each end and one in the middle. When we try to take those elevations and apply them to a flat plane, the center point does not touch the tube. It misses by a foot. That means the pad would be low by 1 foot. On the other hand, when we apply the elevation data to a sphere with a radius of 3,959 miles, the center elevation matches. That's as conclusive a proof as you're ever going to get. Now, hopefully that puts this to rest. Let's move on to Cleary. He thinks he's debunked my video. Oh boy, this ought to be fun.
I am representing the profession of surveying at the moment as an individual.
Okay.
And what does representing the profession of surveying mean? Are you claiming to be a surveyor? Are you claiming you've heard of surveyors? And why are we looking at a lizard?
Well. Blue Marble Science made a video called How LIGO Demonstrates Earth Curvature. How cute, Blue Marble. Well, it shows Earth curvature. Anyway, so what he did was pulled up the blueprints from the supposed, blueprints from the construction of LIGO.
Supposed blueprints. Are you questioning the authenticity of the Caltech website?
And guess what? the elevations match what he would call earth curvature, right? 8 inches per mile squared on his supposed model. But you got a bit of a problem there, buddy. If you got a what is it? It's a pretty well put together video. You can tell he's got some people, you know, working for him, and he's just a good old voice doing the video.
Well, this is my entire staff. His name is Joker. And you're about to have your ass handed to you by a good old boy and a dog.
But what he's got there is an elevation change from the vertex out to the ends. He has an elevation change, okay? Now what I've told him before, and he doesn't seem to get it, as I say, if you survey out 1 mile and you measure an 8-inch drop, what do you call that? An elevation change or earth curvature? And every time he'll go, earth curvature.
And I would be right, too. Take an appropriate device like an auto level or a theodolite. Shoot a proper horizontal 1 mile and measure to a point of equal elevation, and the drop will be 8 inches. Why do you have a problem understanding this, Cleary?
I'm like, really? Okay. So a surveyor who uses a horizontal measuring instrument called an auto level through differential leveling techniques along that mile, not one shot all the way down, no. Taking a foresight and a back all the way through that mile, and you measure an 8-inch drop.
So now you change the rules. It's not one shot, it's not one continuous horizontal line. You want to use differential leveling. That's a procedure that is designed to step you around the curve. Now, these drops that I'm showing in this sketch I made are highly exaggerated. To go a mile doing this, you'll probably take 15 to 20 different shots. The entire idea behind it is to eliminate earth curvature. I really think you're being a little dishonest here.
That's a vertical change from the horizontal. That's called an elevation change, okay? It's not earth curvature. So if you're measuring an elevation change that equates to 8 inches per mile squared over the 4-kilometer distance of each arm, straight arm of the LIGO, which is at a right angle, oddly enough, what you're doing is establishing a horizontal plane, okay? If the terrain varies in elevation from that horizontal, it's not creating a tangent point, okay? You're totally lost. I'm sure people believe what you say, but it's too bad for them because you're a deceiver. That's what you do. That's your job as a debunker. Or deceiver. Well, anyway, yeah, you just make a video and you call it a debunk, and you imagine that you've actually debunked something. But we went through this thing extensively with you, and what you failed to realize is that those mirrors are hanging from a pendulum, okay? That means it's vertical, okay? That laser is shot horizontally from the vertex to the ends of the arms, okay? And those mirrors are on pendulums hanging vertically. So what you establish through that area, and I've told you this, I don't even know how many times. What you're establishing is you have a vertical at the apex, all right? You shoot the laser out horizontally, right? Perpendicular to that vertical. The laser goes out 4 kilometers. You know, most people don't realize how far 4 kilometers is, but go out to like the most level area you know of that you can see really far, okay? And you're probably going to see about a mile, maybe a mile and a half. Probably not, okay? That's a very, very far distance. and 4 kilometers is about 2.48 miles, whatever, down that distance. That's a rough number. I don't know why I have that number in my head. I think it's accurate, but yeah, that's right, 2.48 miles. So that laser shoots out, it bounces off that mirror and comes all the way back. I can't remember how many hundreds of times per second. But what they're demonstrating is Euclidean 3 space, which no one has a clue what that is, apparently. Okay, when you have an X, Y, and Z coordinate system, which is X and Y on the horizontal, and you have the Z vertical, that is a 3-dimensional space, 3D reality. Okay, that's what those vertical pendulum mirrors hanging by glass threads, that's that relationship between that vertical and that horizontal laser is Euclidean 3 space. If you don't know what that is, Google it, research it, figure it out. Otherwise you'll go around embarrassing yourself like blue marble science. But maybe that was just a satirical video. He is a funny guy. Thanks for watching.
You know, Cleary, somebody's going to be embarrassed, all right, and it's not going to be me. I let the last part of your video run because I wanted the audience to hear it uninterrupted. I wanted them to understand what your contention is. You're trying to maintain that because these mirrors are hanging like pendulums, that somehow implies that the verticals, the zeniths, have to be parallel with each other. You couldn't be more wrong. In the first place, they're not single pendulums. There are actually 4 pendulums in series. And the reason that's done is because it multiplies the isolation effect. The entire idea of hanging these mirrors this way is to isolate them from seismic activity. But notice each mirror hangs from 2 quartz fibers. I suppose it didn't occur to you to wonder why they weren't just hanging from one point, like a plumb bob. Well, there's a pretty good reason for that, but rather than try to describe it, I thought I'd just make a little quick video. Y'all watch this. Rather than try to describe this with just drawings, I thought it might be fun just to do a quick demonstration for you. So what I've got is a temporary support up here. It's clamped actually to Cavendish, and this support has 4 wires. I think you can see those pretty clearly. 4 wires that hang down, and let me pan down to our simulated mirror, which is simply a dowel. And I think that looks pretty good right there. So now imagine that the laser beam is striking this face of the mirror, but it's not quite in line. If I pull up on those back 2 wires, what do you think will happen?
Anyone? Anyone? Bueller?
Well, let's see. Uh-oh. The mirror tilts down. And if I pull up on the front wires, obviously the mirror is going to tilt up. So this is how LIGO works. And that's how they adjust the mirror alignment so that the laser is where they want it to be. Now that's not that hard to understand, is it, fellas? Now I know you're feeling pretty bad right now, Cleary. I mean, you know, what with me being just a good old boy and all. But hey, Joker didn't get it right the first time either. So I'll let you and Brian run along now, because I'm sure you guys and your management want to try to figure out how you managed to let a good old boy and a dog make you look so foolish. Thanks for watching. Hope you guys enjoyed it. Next time somebody says, show me 8 inches per mile squared, just show them a picture of that thing. Don't forget those little buttons down there. Shout out to the patrons and the PayPals. And we'll see you guys on the next one.